Today we show the fabrication of cast restorations, starting with the impression of the prepared situation. In this case, the dentist took an impression and did not work with an intraoral scan. Both methods are basically possible. Our impression was filled with plaster to make a plaster model. This is transferred to the digital software in the laboratory using a scanner. In the software, we first receive an image on which we determine the teeth on which the restorations are located. The software then shows us the digital 3D model. This model is then used to define the preparation margins. The dental technician relies on its experience to determine how long the crowns should be. The software marks these areas in gray and thus defines the working areas. Here we see the base of the 4-unit posterior bridge, and the anterior bridge is also prepared. All preparation margins are defined in the software. Now we mark in yellow where a cement gap is needed, so we create space for the luting material, for example BFix QM. Suitable tooth shapes are selected from a library, which are adjusted in position and size. Teeth to be veneered are marked to reduce their shape. Space must be created for the ceramic from which the final tooth shape will later be made by hand. Now the pontics are still in the air, so connectors are needed to connect them with the abutment teeth. The finished frameworks look like this. In the posterior region it is a partially veneered bridge. The premolars will be veneered with ceramic, the molars remain completely metallic. The restorations are then exported to NetFab. The frameworks are first positioned correctly. For anterior restorations, the incisal edge should face the building platform. For posterior bridges, the vestibular surface must be aligned with the building platform. Now we raise the objects to make room for the necessary support structures. These are first placed automatically, and in the red areas supports must be added manually to ensure sufficient stability during printing. In this case, the restorations are duplicated in order to have a replacement in case of a casting failure that can be attached and casted immediately. Then save and transfer. The file to be printed is selected at the printer. Following the printer menu, choose which vat to use, then which material. This is of course the V-Print cast. Then select the build style, insert the vat and fill in the material. Here you can see the blue color of the V-Print cast. Insert the building platform and start printing. In this case, 349 layers are printed in 1 hour 20 minutes. Here you can see the freshly printed frames that are still dripping wet. Now a 15-minute wait is necessary to allow the excess resin to drip off. The restorations are removed from the building platform here, which is easy due to the good green strength. The restorations are now placed in a case for the isopropanol bath with the crown openings facing downwards, so that the rinsed resin can drain off and does not collect in the crowns. The first bath lasts 3 minutes. Then the restorations are placed in the second tank, where they are cleaned for another 2 minutes. Then remove the restorations. Blow away excess isopropanol to dry them. And then simply remove the supports with a separating disc. Here in the company, not only the material is in the focus, but also the handling, and so-called nibble supports have been developed, which can be easily turned off by hand. This is easier and more comfortable. Small protrusions remaining from the supports on the restorations are ground away. Grinding dust is removed, and then the post-exposure takes place. Post-exposure without supports, because these can throw shadows and hinder complete post-curing. We give here 2 times 2000 flashes. Before the second run, let the restorations cool down for 2 minutes. Turn once, close the lid again, and expose again with 2000 flashes. Then, for example, you can check whether the preparation margins were defined correctly. Otherwise, the objects will be modified. This can be easily achieved due to the excellent grindability of the V-print cast. Now the attachment is done with casting reservoirs. Here we will show the attachment of the casting channel. The casting reservoirs prevent the formation of holes in the cast objects. The posterior restoration is placed on the muffle former in addition to the already attached anterior restoration. They should be approximately the same height and not in the center of the muffle, but these are things that dental technicians know. What has to be considered during attachment would go too far here. These are the components of the investment material, which can vary depending on the used investment material. We start with the investment powder. Add the measured investment liquid, as well as distilled water. This mass must be mixed for 1 minute. Afterwards, it is stirred under vacuum for 1½ minutes to obtain a homogeneous bubble-free mass. The muffle former was extended by a muffle ring and muffle fleece. The fleece, shown here in white, is responsible for compensating the expansion of the investment material. When investing, It is important to carefully insert small amounts into the restoration with an instrument in order to prevent bubbles from forming in the edges of the restorations, which can later be found as metal spheres in the restoration, and are difficult to remove. The hardened muffle is then placed in the preheating furnace to melt out the resin and wax, creating a hollow shape. The metal is preheated in the vacuum pressure casting machine. The muffle goes into the vacuum pressure casting unit in a red-hot state. It is then confirmed that the metal is now to be melted. Here the 4 metal cylinders are located in the crucible. They melt into one mass. Then the crucible divides and the metal flows into the muffle. Then pressure is applied to really press the metal into the smallest corners of the muffle. The muffle is removed and cools to room temperature. The next step is to divest the muffle. First, the ring is removed with a pneumatic chisel, and then as large pieces as possible are removed at once to expose the restorations. This is only possible to a certain extent. Invest material in and between the restorations cannot be removed with a pneumatic chisel. This is then removed by sandblasting, as you can see here. Sandblasting has the additional task of removing the oxides on the surface of the metal. These can be seen here in green on the metal. Then the casting bulbs and the casting channels are removed. Projections are ground with a coarse large stone, and the restorations are finished. The areas to be veneered remain dull, and all metal bridge units are polished to a high gloss. We do not show the ceramic veneering here.